trying to not cover too much. There are various ways that you can execute a program. We'll see when we start doing Python, we'll see that you can execute a Python program like something like this, where test.py is a Python file. In the same way, if test is a file that contains a shell script, which is what we'll be doing, then you can execute that by doing bash test. So that's basically telling you, test is a file that contains a program. This program should be interpreted by bash. Goostat is actually a bash script, which is here. So we can look at what's in there. It loops through some options, then it sleeps for 2 seconds, and then it does some head and sorting. So the reason that it takes 2 seconds to run is because it's sleeping for 2 seconds. So it's basically just a toy example of a program that's being run with bash. If the thing that you needed to run was a system-wide program installed on your computer, then you wouldn't need the bash there. Then you would just have the name of the program. Per default, you're not allowed, if you do this, then it won't execute it, even though Goostat is a program in your current folder. That's a security concern in the way that, say that someone created a program called ls and put it into some folder, and that program was actually an alias for removing your entire file system. Then they could trigger you into, when you just ran ls, to remove your file system just by leaving a command, just by replacing ls with something else. So therefore, when bash looks for programs just written like this with the program name, it only searches certain specific directories, so that you can't be fooled into running a different program that does something completely different and unexpected. But doing like this tells the interpreter, yeah, I know what I'm doing, I want to execute this program using in my current folder with bash. We can look a little bit at the questions relating to this. So we're doing ls, that contains 3 different files, and then we're doing a loop over those data files here, and then we're doing ls start.dat or ls data file. So the question is, what's the difference between these two loops exactly in the first one? So the first one is most likely not what we want, because in the first one we'll efficiently replace both of those occurrences of start.dat with the complete list. So we'll first print ls of all 3 files, then we'll run again, print ls of all 3 files, and run ls on all 3 files. Whereas this one will do ls on the first file, and then ls on the second file, and so on. So if we do something like this, for sugar in start.dat, and we've got a number of files again, which are these fructose, glucose, and sucrose, then what's going to happen if we echo and then we cat the file name, so that means showing the contents of the file and piping that into silos.dat. Is that going to print all the file names and then put the contents of the sucrose file into this file? Is it going to print all of them and put all of the contents into that file? Yeah, exactly, because the first time the loops runs, it will write that text to that file, but then it will be overwritten all the time. So if we actually wanted to concatenate it, then we would use the double version here. If you run through all of these .dat files, and then you use the double concatenation into sugars.dat, then all of them will be concatenated. But obviously we won't get the .txt file in there. Yeah, this is perhaps interesting a little. So I showed before how we could use echo to sort of do a dry, what people call a dry run, where you just print something that tells you what was going to happen if I executed that script, but not actually doing it because it's a destructive command that you don't want to get wrong. So you wanted to analyze some file running a program called analyze and piping it into some kind of output. Then you could add an echo to see what's going on. But what's the difference between echo a thing and actually echo the thing quoted down here? The problem is with the first one, it actually does something that you don't want to, because it's echoing the first 2 things, and then it's piping that to a file. So the echo only applies to the thing before the character. which is exactly, it's not what we want. We actually want to echo all of it because we want to see what the command was going to do. So doing the last one ensures that it won't actually execute anything of what's within the brackets. Otherwise it would echo that and then pipe it to the file. I think we'll skip this one with the expression and move on in order to cover some of the last topic before we're done. So the thing that we're missing now is that we've created this pipeline for running the GUI stats analysis, but the only way we've stored it is in our bash history. So while the bash history may store everything you've done, then finding a specific command in your bash history that you ran a month ago is probably going to be a horrific experience, and it may not be there anymore because the bash history has a limited length. So we would actually want to put this into a script that we can run again once we've nailed down what we actually want to do. So that's the next topic that we want to cover, how to actually go about putting this into a script. We've already touched about that because we saw how GUI stats was actually a script that was being run. We're going to start with an example on the molecules again, just to get something basic. We talked about how we could use head and tail to find top and bottom of a file, but we also saw that we couldn't actually, there was no way of getting the middle of some file, because head didn't take a starting position and tail didn't take an end argument, so you couldn't actually with either one of those commands get the middle files. You could combine them to get the middle section of a file, and that's what we're going to see. Try writing a script that can do that. So I'm just nano opening middle.sh, which is .sh is the default extension that most people use for shell scripts, but it's just a convention to help you and the computer identify this as being a shell script. Let's say that we wanted the first 15 lines, and then we want to take off the last 5 lines of that, something like head 15 octane.dat, and then pipe that to tail and take the last 5 lines. So that works. If we execute it the same way we executed the GUI stats program with bash middle.sh, then we can execute it and we get 5 lines here. We can look at what's inside the Octane file. So it looks like we're getting lines from down there somewhere. So that looks about right. Okay, so this is a fairly simple program, similar to what we've been doing now. It's not particularly flexible. In fact, it's very inflexible, because both the starting number of lines and the end number and the file is actually hard-coded in the program. So if we want to run the same program on a different file, we would have to modify the program. Unfortunately, there's a simple way of getting the arguments into a shell script. So one way, the simple way here, $1 means whatever you put on the command prompt after the name of the program will be put in at that place. So if we replace the file name with $1, then we've actually written a program where we can give it a file name as an argument. So now you can execute it as bash middle.sh and then the name of the file that you actually want to run it on. It's probably a good idea to put some quotes around the argument here, because if we had a file name containing a space, it would result in two file names being put to head, which will confuse it. So quoting is a good idea to make this a little bit more foolproof. We can make this even more general by also making these start and end points configurable, so we can put in multiple variables. This means that this will be the first argument after the program name, that's the second one over here, and the third one over there. Again, we might as well quote them. It's probably unnecessary, and the arguments are of course still on the same form as they were when given to head and tail, where you need a hyphen, then the number for start and end.